Okay guys, welcome to today's body composition lab. We've talked about body composition a little bit so far in lecture. Specifically, we've talked about 5 different methods of body composition assessment, 3 of which are up here. So today in lab, we're going to be focusing on the BOD-POD, which is really the gold standard of body composition assessment in most exercise physiology settings, bioelectrical impedance analysis, or BIA, and then skin folds, which many of you have experience with. The 2 others that we talked about in lecture that we won't be collecting data on here in lab is the DEXA, right? And underwater weighing, sometimes also known as hydrostatic weighing. Okay, so those 2 methods we will not be detailing. But these 3 you need to know well. Specifically, when all is said and done, from what we've covered in lecture and what we'll cover here in lab, you'll need to understand the advantages and disadvantages of each of these methods. You'll need to understand the assumptions behind each of these methods, so what we're assuming when we assess, and you'll need to understand, essentially, how each works. And these 2 can sort of go together, because in some cases, when we're trying to understand how each works, we need to take into account the assumptions and the considerations for each. Okay? And we'll talk about those a little bit today as we go forward. Our participant for today, as seen here, is 19 years old. He weighs 75.5 kilograms, and he's 180.3 centimeters tall. And that data is at the top of your data sheet, so you need to make sure to record that, okay? So now we're going to run through the skin fold technique. Skin folds are great because they're inexpensive and they're portable, which is really fantastic. The difficulty with skin folds is that it requires a lot of training, quite a bit in fact, just to see the procedure and understand the procedure, and even more to feel very, very comfortable with the procedure. Skin folds are also difficult because, as you guys have probably noticed, there are many different body types out there with varying degrees of subcutaneous fat in different places on the body. This can be difficult, and really it just requires lots and lots of practice, which you guys are not required to do for the purpose of this class. But I want you guys to understand the procedure and be able to see. So what we will be doing is using 7 sites, and as you guys probably know, skin folds is where we will be pinching certain parts of subcutaneous fat at different locations throughout the body. And so we will take measurements at each of these locations, and we will sum those measurements. Specifically, we're going to do 2 rounds of measurements, and we always do 2 to make sure, essentially, that the first and the second reading at each skin fold site are close enough in agreement. And if they're not, then we need to do a 3rd, okay? But once we have that sum of skin folds, we can plug that into the equations at the bottom of your data sheet, where you'll probably notice if you go look at your data sheet, that will give us density. So we're going to start, and I'm not going to require you to know the different sites necessarily. I'm not going to require you to know essentially how we measure where to take it, okay? But I'm going to show you the different sites, okay? The first of the 7 sites is the abdominal. And by the way, whenever we're doing these skin fold sites, we always do it on the right side of the body for standardization purposes. When we're doing the abdominal, it's 2 centimeters to the right of the umbilicus. So you measure it with our little measuring tape here, and once you have that, you can kind of indicate it with your finger. And when you go down to take your skin fold, you want to reach as far down as you can until you hit muscle. So you want to take as much of the subcutaneous fat and skin as you can. When you bring the calipers in, as you can see here, you want the calipers to not be touching your fingers. You want to have about 1 centimeter in between each, okay? So as not to essentially push the fluids and some of the subcutaneous fat out of the pinch. When you reach in then, you will place the caliper about halfway in between the base and the crest of the fold. For example, this was 11. You release the caliper, then you release the pinch. So that was 11, so I'm going to go ahead and record that now. Always record everything you do. The next is the chest, okay, which is halfway in between here and here, as you can see. So again, I'm going to reach down. I've got muscle. You can slowly retract the pinch, and you'll see the muscle slip out of my pinch there. Bring the calipers in. Again, making sure the caliper placement is about 1 centimeter away from the finger. Take the reading, okay, which in this case was 6. You don't need to record these numbers. I'll give you the sums in just a minute. Next, we're going to do the triceps. So go ahead and turn around here, participant. And when we're doing that, we're typically trying to be halfway in between on the tricep here, and you want to make sure that you're fully posterior, okay? So we're going to take the pinch. I always make it a habit of getting muscle first, again, retracting the pinch until you'll see the muscle all of a sudden slips out. So once you have that pinch, again, you bring in the calipers, and that's 8. And by the way, the abdominal and the tricep, as you saw, are vertical folds going up and down, whereas the chest was a diagonal fold. Okay, thank you very much. The next side we're going to do is the mid-axillary, okay, which is over here on the side. And it's kind of a hard place to get to with the arm in the way. And so when you're doing this, you want to make sure to ask the participant to take their right arm and rest it very lightly on their left shoulder, okay? And not so much that they're stretching the skin or anything of that nature, just very lightly. And it's at the level, here of the chest. So what we do is we're going to draw that over, and then it's at the mid-axillary line, okay? Not the anterior axillary line or the posterior, but sort of at the mid-axillary line here. And it's another vertical fold. So reach down and get muscle, and then let that muscle slip out, and what's remaining is your skin fold. That was 10. The next that we're going to do is the suprailiac, which, if you guys remember from Dr. Morgan's anatomy class, suprailiac, we're talking about the superior part of the hip here, okay? And when we're palpating that, we're actually looking now for the anterior axillary line, which is right at the front of the armpit, okay? So you ask them to make sure to relax their arm, okay? Draw the line down. And this is kind of a ticklish spot on a lot of people, so just make sure you let them know what you're going to be doing before you start digging around down there in their hip, okay? And you're going to find the top of that hip. Now here's where there's some variability, because some people's hips lie a little bit different, right? And are angled a bit different. Some are a little bit higher, some are a little bit lower, some stick out more, some are a bit more visceral, okay? So there's some variability here, but once you find it, you're going to take the skin fold right at that area, right at the superior part of the hip there, okay? And as you're doing it, the fold is typically diagonal, but it's really just in line with the hip. So if their hips are a bit more forward, it may be more horizontal, for example. In this case, he's pretty diagonal. Again, you bring the caliper in, about 1 centimeter in between the caliper placement of the fingers, and you take your reading. Our 6th skin fold is actually my very favorite skin fold. Go ahead and turn around, Mr. Participant. This is the subscapular, by far my favorite skin fold. And sometimes it can be hard to find, especially when your participant has a fairly muscular back. Sometimes if you're palpating, you can find it. What you're really looking for is really the inferior angle of the scapula, which sticks out in some people and others it doesn't. But there's a little trick to help you find it clearly. If you ask them to take their right arm and reach it behind their back as if they're trying to scratch their back. Go ahead. See how it sticks out right there? There's that inferior angle. Now it's going to slip back when he relaxes his arm. So find it with your thumb, then ask him to relax their arm, okay? And you've got that inferior angle. You know exactly where it is. In this case, the skin fold is about 2 centimeters below that inferior angle. So if my thumb is right below the inferior angle, we know that, well, thumb's about 2 centimeters wide. And there's the fold. And it is a diagonal fold, okay? Reach down to the muscle, make sure the muscle's not in the pinch. You come in, you place the calipers, you take your reading, and we're done with that. The last reading is the thigh. Okay, now the thigh can be difficult to get to. It's typically sort of midway in between the patella and the point at which, when we raise our leg up, where we see some division there. So go ahead and raise your leg up for me, okay? And we're going for about halfway in between. Good. Now go ahead and lower your leg. You kind of mark that with your finger, okay? And the one thing you're going to want to ask them to do when you're doing a thigh skin fold is to place their right foot on their left. So just the heel of their right foot on their left. So go ahead and do that. Because when we stand, we don't think about this, but when we stand, we're actually flexing that muscle. And it makes it... You have a hard time standing there?
I'm not good at balancing.
You're not good at balancing. Okay. It actually there's a lot of flexion going on in the muscle, so it makes it really difficult to get a good skin fold. But if you ask them to put their right heel on their left foot, that completely relaxes the quadriceps and allows you to get that skin fold. So you mark that area, ask them to pull up their compression shorts if need be. Okay. This one can be really difficult because legs are often very muscular. So you want to make sure that you get really deep and get part of that muscle. slowly retract the pinch, and you'll see it slip out. Okay, see that? So the muscle slipped out, and what remains is the subcutaneous fat. Reach in, take your skin fold, release the skin fold, and then release the pinch. If you release the pinch before the skin fold, it's going to hurt, right? So what you just observed was round 1 measurements. We also did a second round, and as you can see, the measurements are fairly similar. That's good. It means that we're in agreement, and typically it means that you're fairly well trained, obviously. So what we do in this case is we take the average, which you guys will not need to do for the exam or anything to that nature, and then what we did is we summed the average of these 2 rounds. And the sum of skin folds, as you can see here, is 74.5. So that will be very, very important, that number, because you're going to put that in your sum of skin fold equations at the bottom of your data sheet to give you the density for skin folds, okay, which will go into your table. Bioelectrical impedance analysis is another method of body composition assessment. Some people consider these to be random number generators. I wouldn't go that far, but it's certainly not my top choice, even compared to skin folds. Now, BIA devices come in a very wide range of appearances and even methods. But the whole principle behind bioelectrical impedance analysis is that a small current is passed through the body, is conducted through the body, and the extent to which that current is impeded dictates essentially how much fat an individual has. Because the assumption here is that water, which is in muscle, will conduct this current, but that fat will impede this current. So the more the impedance, obviously, according to BIA, the higher the amount of fat. Now there are some glaring limitations with that, one of which is hydration status, which we've talked about a little bit already in lecture. As I mentioned, BIA comes in many different forms. If you go to a gym or to a training center or something, they may have these little handheld ones, and they may even try to convince you that they are highly accurate. As we talked about in lecture, I'd be very careful of that. Even the most expensive BIA devices, such as this here, which is over $1,000, believe it or not, has some severe limitations, what with hydrational status. So again, I'd be very careful. The nice thing about BIA is there's no more easy method of body composition assessment. Literally within seconds, you can have a percent fat value. The question that I would pose to anybody that argues BIA's overall merit without noting its limitations is whether or not a quick and easy number is any good if we're not certain that it's valid or accurate. So take these things into consideration. I don't believe these devices are universally bad, but I also believe you should be very, very cautious when interpreting any kind of data from them and ensure that the participant is well hydrated. So let's go ahead and show you this BIA device. It's really quite simple when you're doing it, and some of them are fairly user-friendly because BIA, the different companies, are trying to market these devices to health clinics and personal trainers, even out of your own home. And so they're about as user-friendly as it gets. Now, what I was trained on when I was younger, the original BIA devices looked like jumper cables. They didn't look anything like this. And they would kind of attach these jumper cables to you via some stick-on electrodes. And it would measure resistance and reactance, which you will actually see in the BIA equations on your data sheet. Now, the BIA devices these days don't do resistance and reactance. They don't give you those numbers. They calculate it for you within the software. So you'll just get percent fat. Still, I wanted you to see the original BIA equations so that you could essentially understand the role that resistance and reactance played in calculating percent fat for BIA. Notice with BIA that body density does not feature into the equations. Unlike skin folds and bod pod, body density with BIA is not important at all. Okay, so when we're doing this particular device, and you guys obviously do not know how to do this, we'll turn it on, obviously. The first thing it's going to ask for, essentially, is how much weight for an individual's clothing. Our participant is in skin-tight compression clothing, so we're going to lower this down to 0. Okay, and we're going to continue on here. Okay. The next thing that we're going to do is signify that yes, he's indeed male and he's an athletic male. Okay. It has a setting for more sedentary male or female and more athletic male or female. We're going to enter that in. Okay. And we're going to put the height in, which was in inches. About how tall are you in inches?
5'11" to 71.
What's that?
71.
71 inches, okay. So we're going to raise that up to about 5'11". As you can see, this is meant to be extremely user-friendly to the point where you question some of the assumptions the device makes. Okay, and then we're going to ask the participant to step on, obviously, bare feet so we can have a good conduction. Yep. And all of a sudden, boom, up comes the percent fat, 8.5%. Go ahead and step off. So with respect to BIA, it's really that simple. And it's almost too good to be true, right? I'm not saying, again, that BIA is a complete waste of time, because I don't think it is. It can be very useful. But I think we need to be very, very careful of anything in our field where it's just like that. You get a very complicated variable very quickly, okay? Regardless, our participants' percent fat from BIA was 8.5. No density needed in this calculation. As we talked about in lecture, the BOD POD is really the gold standard for body composition assessment. You can make an argument for DEXA, which certainly has its advantages, but as far as the most valid and most practical devices, the BOD POD really is the top of the top. It used to be hydrostatic and underwater weighing, but because the BOD POD is so much more feasible and really sort of uses some of the same assumptions and some of the same principles, we just do this. It's so much easier for the participant. There's a lot less cleanup. It's not uncomfortable at all. So it's really the premier choice. Now, we've already calibrated the BOD POD. Because it's such an expensive instrument, it really goes for quite a bit of money. At any time you're using an instrument of this magnitude, it requires a fairly extensive calibration process. And if anything is out of whack with that calibration, we will not get a valid reading. So we've already done the calibration, we're ready to go. And so essentially, before the participant gets in, the only thing we need to do is the sort of initial test before he gets in. And that is with this guy here, which is a known volume. And so we know that if the BOD POD gives us essentially the value of this volume, then we know that the BOD POD isn't having any pre-test issues before our participant gets in and needs to essentially give us an accurate volume measurement. So essentially it's fairly easy. I'm going to put in the participant's information first. Before we can get our participant in the BOD POD, we need to run through these those pre-assessments, as I mentioned, and it's pretty user-friendly. It didn't used to be that way, but software has gotten better and better. So the first thing it's asking us to do is to open the BOD POD, and then close the BOD POD, and make sure to spell out every single step, okay? You need to open and close very carefully because the seal around it is very, very important. And then it's going to go through sort of a pre-calibration process. This isn't the big calibration I was just talking about. This is just a mini one we do before every single test. So first it wants to do a sort of a calibration assessment before we put in our known volume. And then after that we can put our participant in. Fairly simple, fairly basic. So we'll wait for this calibration process to get done. And by the way, when the participant's actually in the BOD POD, they can't hear much. They can hear a little bit, but they can't really hear much because in there some of the sounds are amplified. Some of the air rushing in and out. Some pops here and there as the seal shuts, for example. And they might feel some pressure on their ears, as if maybe taking off on an airplane. That can be a bit worrisome to a participant unless you tell them beforehand. Once you tell them, it's really not an issue, but if you don't, they'll be concerned. Okay? So now it's asking us to do this secondary mini calibration by putting in our known volume. We'll close the door and start that measurement. And while that's happening, we just need to make sure that our participant isn't wearing any kind of jewelry or anything to that nature which could potentially influence the volume measurement or the pressure measurement. Okay, no glasses, no socks, minimal clothing. Okay, so compression gear. Once we do that, we can actually get mass. This is very, very important. We have a highly accurate scale down here. Okay, we're going to click to tare the scale. And then we can ask the subject to come on over and have step on the scale. And once we do that, we just need to make it clear that they need to hold as still as possible. We're going to measure it. Now, Mr. Participant, when you are done, when I ask you to step back, don't turn around, just take one step back and off, okay? Okay, now you can take a step off the scale. And we are just about ready to go. We're going to ask him to put on this sort of lycra hat here that compresses any hair or hair volume that they have. Again, that's very, very important that we minimize that. So now we can take out our cylinder here, and we can ask the individual to enter the bod pod. And the key went in the bod pod. So we'll do 2 different readings. Each takes about a minute. That's about it. And if those 2 aren't close enough, then we'll have to do a third. But the key here is to ask them to hold as still as possible. So usually we ask them to keep their hands sort of in their lap and to breathe normally. Now, it doesn't mean deep, deep breaths. It means sort of shallow breaths. But the key is that they hold as still as they possibly can. They need to look straight forward. They can't move their head, no smiling or laughing or anything to that nature. The key is to hold as still as they possibly can. Okay? Ready to go? Mm-hmm. Okay, hold still. And as I mentioned, there will be 2 separate tests. Okay, so the first one is done. We'll open up the bod pod, make sure they're okay. Tell them we're going to do exactly the same thing and remind them to hold still. Here we go. And again, we're going to shut the door very slowly just to make sure the seal isn't damaged. Okay, we are done with the test, and it appears that the results are close enough between the 2 tests, so good sir, you are finished. And that concludes our bod pod test. As we've discussed, density is really the key for skin folds and for bod pod specifically. You have to get density before you can make any of these other calculations, but once you have it, you're solid, you're golden. Okay? So density, which is sometimes signified in mathematical equations as dB, which is what you'll see, is really the most important piece. Specifically, there are regression percent fat equations, which are population and age specific. And so 2 of the more common we have written here, one for males and one for females. This top one for males is actually called the Surrey equation, S-I-R-I, the Surrey equation. And as you can see, it's very simple. 4.95 divided by density minus 4.5. So let's just say that someone's density, I know we've already collected data on our participant, but let's just say, hypothetically, someone's density was 1.05. Very simply, what we do here is replace we just insert this number, 1.05, and that will essentially give us the value for percent fat. Let me check here, it's on my calculator, 0.214. Or if we're talking a percentage, percent fat, we're talking 21.4% fat. Okay, so that's how we would calculate percent fat from density for both skin folds and for the bod pod. Once we have percent fat, that opens up a host of mathematical equations that we can perform, specifically looking at how much fat mass we have and how much fat-free mass we have. Now, as we've indicated already, by this point, we should have an individual's total mass, or weight, okay? So if we have the total mass, and we have the percent fat, we can figure out how much fat mass and how much fat-free mass an individual has. Specifically for skin folds in the bod pod and also underwater weighing, this is possible because we assume a two-compartment model. And if you recall from lecture, a two-compartment model simply means that fat mass and fat-free mass equals total body mass. Or in other words, if it's not fat-free mass, it's fat mass. And if it's not fat mass, it's fat-free mass. So this equation here allows us then to take the next step. Total mass equals fat-free mass plus fat mass. So we've got that written right here, okay? So if we have an individual's total mass, okay, and we have a good idea of what their percent fat is, then very simply, using this equation right here, we can derive what their fat mass is. We just have to isolate it on one side algebraically, okay? And then to do that, if we were to discover what someone's fat mass is, we can plug that in this equation here and get their fat-free mass. Because if we know their total mass, or their weight, and now we know their fat mass, just through algebra here, we can figure out what someone's fat-free mass is. So continuing on with our example here, if we're trying to figure out what someone's fat mass is, we already know what their percent fat is. We figured that out. So let's go ahead and throw that into this equation here, okay? So we know that the percent fat was 21.4%. We're going to put that in here actually as a decimal, okay? So 0.214. Now let's just say that our individual's total mass is 90 kilograms. Okay, so again, we're assuming that two-compartment model. And so basically what we're assuming here is that 21.4% of an individual's total mass or weight is fat, and this is their total mass. Okay, so very simply, when you multiply this together, this gives us a fat mass of 19.26 kilograms. That's our fat mass. So now, if we continue up here to this equation, very simply, we know that the total mass, again, is 90 kilograms, and we know that the fat mass is 19.26 kilograms. Well, then it's very, very easy to figure out what the fat-free mass is. Very simply, we would just subtract 19.26 kilograms from 90 kilograms, and that's going to give us our fat-free mass. Okay, so this table here on the board is essentially the table that's on your lab assignment and that you need to complete. So I would advise you to have a look at your lab sheet now. When completing this data sheet, you need a few points of data. And as I mentioned, for both the bod pod and for skin folds, you need to start with density. That's the key. Because if you have density, then you can get percent fat, and then you can get fat mass and fat-free mass. Okay? The density as measured by the bod pod that we just did on our participant was 1.084. That's 1.084. The density for skin folds, I'm going to have you guys calculate based on the equations that I just showed you that are on the bottom of your lab sheet on the very front page. Bear in mind for that, there are skin fold equations for both men and for women, and since our participant was male, you'll want to use the skin fold equations for men. Notice the outcome variable for that equation is dB, or density. So you plug the sum of skin folds into that equation to get density, and once you have density, which may and probably will be a little bit different than the bod pod's density, you'll use the same formulas that we just showed to calculate percent fat, then fat mass, and then fat-free mass. But the key is really getting density for each. Now please bear in mind, when you're calculating density for skin folds, those skin fold equations have a lot of zeros in them. They're very, very specific. And if you miss a zero, or you put the decimal in the wrong place, or you don't obey the order of operations, you're going to get a pretty strange number for density. But just as a general rule, density almost always will be at a range of 1.0 to 1.1, somewhere in there. And if you're getting something drastically different than that, you've done something wrong in the calculation. So you have bod pod's density, you're going to get skin fold's density, and then you'll use the same population-specific percent fat equations to get percent fat and then go from there. Now, BIA is a little bit different, and as we just showed you on the sheet, we have BIA equations there. And I mentioned to you that in the past, BIA was a lot different than what it is now. Now, you just step on a scale and in a matter of seconds, up pops percent fat. And so, although the BIA equations are here on the sheet, you will not be using them because we're not giving you resistance and reactance. So what you'll do simply is put in the percent fat value that we just showed and that we just found using the BIA device, which you guys should now have. And once you have percent fat, as we talked about previously, it's very easy to calculate fat mass and fat-free mass because you have your participant's weight or total body mass. This concludes today's body composition lab. I hope you've enjoyed it, and now hopefully you can answer those questions on those 3 things that I asked you to know at the very beginning of our lab today. You have the data, so you should be able to complete questions 1 through 8 on your lab. We will likely be doing this in class unless I instruct otherwise, but thank you for viewing the lab today.